Hi class, this lecture continues talking about solving trigonometric equations. So this is the lecture number 2 in this series. And so what I want to go back is I want to show you, we talked about how you solved these type of just very simple trig equations. And now what I want to do is I want to talk about how you solve multiple angle trig equations. All right, so let me give you the example to start. So the first problem we did was when sine of x was equal to the square root of 3 over 2. All right, let's try this one. Let's look at example 8 here. This will be something like this. Let's solve sine, and when I say multiple angles, it'll be 2x instead of just x. That's where the multiple comes from. So sine of 2x is equal to the square root of 3 over 2. Okay, and here's what I want to do. I want to find, I want to do two things. One, I want to find, I'm going to do these backwards actually. All solutions. And then two, I'm going to find the solutions on from 0 to 2 pi. Okay, and actually this is the harder part here. Finding the general solutions is pretty easy, but then when you restrict it, you can see it's a little bit harder. All right, so what you do here, okay, is ignore, the first thing you're gonna do is just say, okay, this two in here, that's gonna change the period of the sine function, right? Our period is no longer 2 pi, it's 2 pi divided by b, so our period is pi here, basically is what's going on. All right, but the procedure is the following. You just start by looking when just sine of x is equal to the square root of 3 over 2. That's the first thing you're going to do. Just when does sine of x equal square root of 3 over 2? Okay, so let's look. That's here, that's pi over 3, and that's here 2 pi over 3. Okay, so this is when we are at pi over 3 and 2 pi over 3. Okay, that's just when x is. Okay, so all you're going to do here is you're going to take this, all right, whatever's inside the trig function, 2x, okay, and you're going to set it equal. All right, you're going to go pi over 3, and then the general solution previously was pi over 3 plus 2n pi, or 2 pi n, excuse me. And then the other one was 2 pi over 3, so then you take 2x and set it equal to 2 pi over 3 plus 2 pi n. And this is where n is any integer. And all you're going to do is now just solve for x, okay? So this step 2, here what you did next, set the original inside equal to those solutions and solve for x. So all you're going to do is you're going to divide everything by 2. Okay, so pi over 3 divided by 2. So our new solution, so the solutions to this equation, sine of 2x is equal to the square root of 3 over 2. So I divided by 2. So x is equal to pi over 6, and then the 2's cancel, plus pi n. And then the other one here, when I divide by 2, this would be 2 pi over 6, or pi over 3, plus n pi, or pi n. Okay, and this is, in both cases, for any integer n. All right, so that's just how you find all the possible solutions. Okay. Now the next part, how you find it on 0 to 2 pi, is a little bit harder. Okay. And what you basically have to do is you're going to start with each of these. Okay, so you have pi over 6 and pi over 3. And you have to say, okay, I can add a pi to each of these, okay? I can add 1 pi. I can't add 2 pi because then I'd get over 2 pi. I could add 1 pi to each of these, okay? So what you basically can do is you can have n equal 1 here. So one solution is pi over 6. And then another solution is pi over 6 plus 1 pi. Well, what is that? That would be 6 over 6 pi or 7 pi over 6. And then I could have pi over 3. And then I could have pi over 3 plus pi. And what does that get me? Well, that would be 3 pi over 3, so that would be 4 pi over 3. And so you have 1, 2, 3, 4 solutions here. Okay, just between 0 and pi. Because if you were to add, if n was equal to 2, right, then you would get some number greater than 2 pi here. So your solutions here, you generally are going to put them in order. Okay, you would start with pi over 6, pi over 3, 7 pi over 6, and then 4 pi over 3. All right, so to recap, here's what you did, okay? You looked and said, where does the general function equal square root of 3 over 2? All right, and then you found the general solution for that, okay? And then you just set the inside of whatever this function was equal to the general solution and just solve for x by itself, okay? All right, let's do one that's a little bit harder. All right, so this is a sine one. Let me do a cosine one here. So this is going to be a lot of work, you're going to notice, okay? So originally, again, so finding all the solutions are going to be easy, and then when you find just the solutions on 0 to 2 pi, it's going to be a lot harder. Okay. All right, so let's solve. Okay, let's look at cosine of 4x is equal to 1/2. And again, let's find all solutions. And then 2, let's just find the solutions. Again, just on 0 to 2 pi. Okay, so the first thing you're going to do, all right, again, you're just going to say, okay, I want to figure out when cosine of 4x is equal to 1/2. So you're going to start by looking and say, okay, where does cosine equal 1/2, okay? So it's going to be at pi over 3, and then, where's the other time cosine is equal to 1/2? 5 pi over 3, way down here, okay? So we've got cosine of x is equal to 1/2. All right, again, at pi over 3 and 5 pi over 3. All right, so this is what you do next. You're going to take the whatever's inside here. Remember, you're going to set it equal to the general solution, which was pi over 3 plus 2 pi n. Okay, and then also you're going to need to take 4x and set it equal to 5 pi over 3 plus 2 pi n. All right, you're going to need to solve for x by dividing everything by 4. All right, pi over 3 divided by 4, this becomes just pi over 12 plus 2 pi over 4, well, that's just pi over 2 n, okay? And then over here, you get this, when you divide by 4, you get 5 pi over 12 plus pi over 2n, okay? And this is where, or for any integer n, okay? This is where things get a little bit more complicated. Okay, the general solutions are easy. All right, now again, what we want to do is we just want to find all solutions on 0 to 2 pi. So look, what can n be then? N could be 1, n could be 2, or n could be 3. N couldn't be 4 because then you'd be adding 2 pi. So you need to find all solutions when n is equal to 1, 2, or 3. All right, so as long as you take n, whatever n is, and you multiply it by pi over 2, as long as it's doesn't become greater than 2 pi, you got to figure all this out, okay? So look, it really, really helps just to rewrite this. Plus, get a common denominator here, so this would be plus 6 pi over 12. All right, and then the other one would be 5 pi over 12 plus 6 pi over 12. Okay, so that way you have a common denominator and you can just very, very easily figure out what these solutions are. Okay, so I have pi over 12. And then, look, when n is equal to 1, I have 6 pi. Pi plus 6 pi gets me 7 pi over 12. When n is equal to 2, I have 12 pi over 12 plus pi. That gets me 13 pi over 12. And then when n is equal to 3, that gets me 18 pi. 18 pi over 12 plus pi over 12 gets me 19 pi over 12. Now I got to go down here, okay? I start with 5 pi over 12. Okay? And then add a 6 pi. 6 pi over 12 when n is equal to 1, okay? That gets me 11 pi over 12. When n is equal to 2, that gets me 12 pi over 12. Well, 12 pi plus 5 pi gets me 17 pi over 12. And then finally, when n is equal to 3, okay, I get 18 pi over 12. Okay? Plus 5 pi over 12 gets me 23 pi over 12. Yeesh. So there's, this is why it's crazy, right? It's very, very complicated. Very, very complicated. All right. This is why it's so much easier to find the general solutions, right? And then it's a lot harder to find just this on this very, very small one. All right, let's do one last one. So we've done a sine and a cosine. Let's do a tangent one that's a little bit complicated. All right, so this will be example 10 here. All right, let's solve tangent of x divided by 2, all right, is equal to the square root of 3 over 3. All right, let's find 1, all general solutions. And then 2, let's find all solutions on 0 to 2 pi. Okay, what's really confusing is this square root of 3 over 3. So remember, this right here is the rationalized version of 1 over the square root of 3. Okay, that's what this is. It's the same thing. Like if you were to rationalize this, you get this. So you had to recognize it. That's the first step. And then look, you see how you have all these 1/2 and 3/2 over 2? If you could find it such that I have 1/2 divided by the square root of 3 over 2, when you do keep, change, flip, you'll get 1 over the square root of 3, which is the square root of 3 over 3. So you're looking, when does sine of x be 1/2 and cosine is the square root of 3 over 2. All right, so you want sine to be 1/2, and cosine to be the square root of 3 over 2. And then look, you could also have them be negative, negative, which would be right there. But remember, the period here is pi. So really what you're going to do for the general solution, okay? So tangent of x is equal to the square root of 3 over 3 at pi over 6. So what you're going to do is you're going to take this x divided by 2 and set it equal to pi over 6 plus n pi. Okay, you don't need to do the 7 pi over 6 because that's when n is equal to 1. So then basically what are you doing here to solve it? Okay, you're just going to multiply everything by 2, right, to get rid of the divide by 2. So you get x is equal to, when you multiply by 2, you just get pi over 3 plus 2n pi. That's the general solution. And then the solutions on zero to 2 pi. Well, look, you can't even add it. You can't have n equal 1 here. You can't, because then you would get over 2 pi, because you get pi over 3 plus 2 pi. So it's only x is equal to pi over 3. And we got it. All right, so again, just to recap. All right, and I know that none of this is easy, right? But to recap, you look where the general function is equal to, in this case, square root of 3 over 3, or where does cosine equal 1/2, where does sine equal square root of 3 over 2. And then you just set the inside equal to whatever those values were on the unit circle. Then you just solve to get x by itself. That's the general solution. And then you just figure out how many times do you have to let, what numbers can n be such that your solutions are between 0 and 2 pi. All right, class. Again, I'm always here to help. And, you'll get a chance to practice this on assignments.